With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so our question is, a wooden block of mass 0.5 kg and density of 800 kg per meter cube is fastened to the free end of a vertical spring of a spring constant 50 Newton per meter fixed at the bottom. If the entire system is completely immersed in water, find the elongation or compression of the spring in equilibrium and the time period of the vertical oscillation of the block when it is slightly displaced and released. Okay, so what we have been given that the entire system of our spring and mass system is submerged into water. Okay, so let us suppose that this container is completely filled with water and a vertical spring is fixed at its bottom, and the top of the free end is carrying the weight of 0.5 kg. Okay, the spring constant K of the spring is 50 newtons per meter. Okay, and the density of the block is given to us is 800 kg per meter cube. Okay, now the whole system is filled with water. Okay, now at equilibrium we have been asked that what will be the elongation or compression in the spring. So at equilibrium what will happen is the spring force will be kx acting vertically upwards. Okay, the weight of the block mg will act vertically downward and the buoyancy force applied by the water will act vertically upward. So at equilibrium what will happen is the buoyancy force plus the spring force will balance the weight of the block. Correct. Now the buoyancy force is given as density of fluid into g into volume displaced plus kx will be equals to mg. Correct. Now the entire system is submerged into the water, so the volume displaced will be equals to the volume of the block. Correct. And the volume of the block is given as mass of the block upon density of the block. Correct. Plus kx will be equals to mg. Now substitute the respective values. The density of fluid is 1000 kg per meter cube into acceleration due to gravity into mass of the block is 0.5 divided by density of the block is given to us is 800 kg per meter cube plus spring constant K is 50 Newton per meter into x will be equals to mg. M is 0.5 into g. Correct. So from here we get our x come out to be minus 0.025 meters, or what we can say x will be minus 2.5 centimeters. Okay, let me write it clearly, minus 2.5 centimeter. Okay, the negative sign over here is representing that the spring is compressed, correct, or what we can say is the depression in the spring or the compression in the spring, not depression, let it be compression. Okay, so compression in spring will be equals to how much? 2.5 centimeter. Okay, now in the second part what we have been asked is we have to find the time period of the vertical oscillation of the block when it is slightly depressed and released. Okay, so let us suppose that this block is slightly depressed with a distance of x meter. Okay, now since the whole system is underwater, so the buoyancy force does not change. Correct. Since the volume of the water displaced is not changing. Correct. So the unbalanced force will only be due to the spring. Correct. So for the second part, B part, the unbalanced force F will be due to spring and will be equals to kx. Correct. And the force is also written as mass into acceleration will be equals to k times x. Acceleration will be k by m times x, and for SHM we know that acceleration is omega square x. Correct. So it will be omega square x will be equals to km into x. So from here x and x got cancelled out, so omega comes out to be under root k by m, and as we know that the time period is given as 2 pi by omega, so it will be 2 pi under root m by k. Correct. Now from here, substitute the respective values. So the time period will be 2 pi under root m is given to us is how much? 0.5 kg and k is 50. So from here we get 2 pi by 10, or what we can say is pi by 5. So the time period of the oscillation comes out to be pi by 5 seconds. Okay, so this is the required time period of the oscillation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.